The question is, if a point px comma y lies on the curve y is equal to f of x such that limit x is tending towards 1 and y is tending towards 2 of this given function exists. It is given that this limit exists. Then we have to find the value of limit x is tending towards 1 by 3 f inverse of x upon 3x minus 1. Here this is f inverse of x. I'm going to start the question by evaluating the limit. Later on I'll calculate the inverse of the function. Let's start with the limit. Limit x is tending towards 1 and y is tending towards 2. Simply I'm going to apply a formula of tan inverse of x plus tan inverse of y. Here I need to check the product of the input is greater than 1, then a different branch will come. If the product of input is less than 1, then simply I can add these two. So I can write this as tan inverse of x plus 1 by y whole divided by 1 minus x by y I can write here, minus tan inverse of 3 here. Now whole thing is divided by x minus 1 I'll keep here and y minus 2 I'm going to throw outside. That is sin inverse of y minus 2 and I'm going to divide by y minus 2 here. Now again I'm going to continue the limit. Limit x is tending towards 1 and y is tending towards 2. As you can see here, I can apply the formula here, tan inverse of xy plus 1 upon I can write this as y minus x minus tan inverse of 3 whole divided by x minus 1 multiplied by sin inverse of y minus 2 upon y minus 2 is given. Now they are saying the limit, this particular limit exists. As you can see, if y is tending towards 2, then this is sin inverse of 0 upon 0, so this will be 1. Now let's check the left hand side part. So I think if x is tending towards 1 and y is tending towards 2, this part should be tending towards 0 because numerator should tend towards 0 and denominator should also tend towards 0. And yes, denominator is tending towards 0. There's a note you should write here. This is very important, that if denominator is tending towards 0, in order to limit to exist, the numerator should also tend towards 0. That means here tan inverse of xy plus 1 upon y minus x should be equal to tan inverse of 3 here. Now if they are equal, I'm going to compare the inputs. I can write xy plus 1 whole divided by y minus x is equal to 3. I'm going to cross multiply here. We'll get this as xy plus 1 is equal to 3y minus 3x here. Now from here I'm going to write the value of x. The value of x will be, I'm going to take 3x on the other side. So we'll get this as 3y minus 1 upon, you can say here 3 plus y. So this is the value of x in the terms of y, and I think we got the inverse of the function. So inverse of the function can be written as, here I can write the inverse of the function. F inverse of x, as you can see, f inverse of input is 3x minus 1, 3 times input minus 1 upon 3 plus input. So I think we got the inverse of the function. Now I think we can calculate the limit, which is including inverse. Now we have calculated the inverse of the function. Now I'm going to calculate the limit. Limit x is tending towards 1 by 3. Now simply I'm going to plug the value of f inverse of x here, that is 3x minus 1 whole divided by 3x minus 1. Now one more term is remaining in the denominator, that is 3 plus x here. Now I'm going to cancel these two terms, and as you can see the indeterminate form is removed. So I'm going to plug the value 1 by 3 here in order to calculate the limits. The value of the limit will be equal to 1 whole divided by 3 plus 1 by 3 here. So I think the final answer of the limit will be, as you can see here, 3 by 10. 3 by 10 will be our final answer, and that will be